work done on different situations, and finally we reached to the concept of work done. Yani we have completed that. In today's lecture, we will talk about the energy, okay, and I mean energies specifically, and then inshallah I will move towards the power and efficiency and so on. Okay, so when we talk about energy, energy has a lot of discussion. This topic, there are three type of energies we will discuss here. One is your uh, kinetic energy, right? The second, what I would like to discuss in this topic, that is your potential energy, right? And then potential energy will be further divided into two. That will be your gravitational potential energy, and to somehow elastic potential energy. I will talk about that one, and then we will solve some of the questions. Okay, and third, what we want to discuss here, that is the energy losses. Energy losses are basically in the form of friction. So when we talk about this all, first of all, let me tell you that energy is basically nothing but ability of doing work. So when we say that energy is ability of doing work, then it is actually measured in terms of work, na? Simply it is work, nothing else. So when you talk about that, it means that its unit would be joule, because it is work. Is it?
Yes.
Same as that of your work. And there are different forms of energies, or you can say types of energies, right? And those all types are studied in different areas. That is, I can say, one of them is mainly mechanical energy, and then electrical energy, thermal energy. There are so many, right? Then nuclear, and so on, right? So these are basically the main energies you have uh, yani listen or you have heard about. Then solar energy, right?
So
Yes.
I have a bit unrelated question. So
Mm-hmm.
power is like rate of transfer of energy, right?
Hmm. Exactly.
So we can say like power is rate of change of energy. Can we say that?
Exactly. Rate of change of energy, or rate of doing work, or rate of
So in
transfer
a
of energy.
in an equation, let's say we have an equation which expresses energy.
Mm-hmm.
If I differentiate it, will I get power?
Hmm. uh for example, the power is d by dt of your energy. Got it?
Can we do that?
Yes, why not? So
Okay.
F into Yani, you can write that what is the formula of energy, that is F into D basic formula. Okay, and then that is Yani, it is applied, sorry, D by dt on that one. If we apply D by dt on that one, then it will be D by dt on that one. Then your F will be taken out common, and you will say that d of this, okay, let me write it x to avoid the misconception. It is F into x, right? X is basically, or S is displacement, S, write it as. Okay, are you getting it?
Yes.
So d by dt of the displacement is your V, which is your power.
Okay.
Got it? You can do this for every type of energy, I mean energy, but you must now that the derivative of that variable would be equal to what? For example, if I go to the derivative of half mv square, then m 1 by 2 is constant, it will be taken out. M is constant, it will be taken out. So derivative will be applied at what? Velocity.
Oh,
Okay,
yes. Yes.
right? So you can do that. Let's say um, 1 by 2 mv square, it is d by dt of that. So 1 by 2 m will be taken out common, so you will apply derivative at v. So it will become 2 uh, 2d sorry 2v into dv by dt. Is it? Are you getting my point?
Yes.
So derivation is done like this. So it is dv by dt is this ma, right? So this is basically what that is. In this case, that is your force. So if I multiply that with uh, one more velocity, then I can get energy power. But here maybe we are having some sort of single derivation or double derivation. I don't know, because I am out of derivation for a long time.
Okay.
Okay. So I believe that I have given you the technique. So I believe that because you are in the mathematics and you have very good grades in add maths also.
Uh,
Okay. So yeah, you got it. Is your concept clear?
yes.
Hmm.
Yes.
Okay. Go back to the topic. Let's go back to the topic. Then we will talk about mechanical energy here in this section, discussion. Thermal energy, which would be due to friction. Okay, that is due to friction. Electrical energy can be used when I say that the object or the body is electrically operated with the help of motor or something like that. Nuclear energy is usually not discussed here. Okay, and solar energy also. So here we will do mechanical energy. So if I say what a mechanical energy is basically, here I'm going to write here, that is energy due to motion of a body or change
Mm.
in position, right? Energy due to motion and change in position. Change in position. So if a body is there and that body has yani that is moving, it means it will have some sort of energy possessed by it, and that energy will be definitely considered as kinetic energy. Okay, do you believe that? Here we have some derivation also, and that derivation will help us out to find whether yes it is true or not. Okay, so I will do that derivation for you also. Secondly, we will have the interconversion concept. Just me set my position. I have been displaced, so rate of doing work is applied on me by my kids. They are just they have displaced my position. Sorry, because they are going to play the game now, and you know when this all is happening. Okay, to if you just allow them to play game, they can set everything for you. Yes. Okay, so sorry for this bad interruption. That mechanical energy, the energy due to motion and due to basically change in position. So when I talk about that, um I realize that this energy is of two further types: kinetic energy and potential energy. Because in potential energy, we have this yeah, I mean, this tendency that the body will change its motion, and when the body will change its motion, that will be done by its speed and all that stuff. Okay, let me check that what happened to my laptop here, why it is being stuck again. Maybe no. Okay, yes, they have changed the position, and my laptop, this, that is an old machine, and in old machines you are not supposed to disturb them. When you will disturb them, they will be gone. So that is why, yes, now it would be settled maybe, or may not. It depends. Oh, sorry, yaar, your class is just okay. So I was talking about that either we have to talk about potential energy and gravitational potential energy. So kinetic energy is basically the energy due to motion of a body. So when energy is due to motion, I mean speed and mass of the body, it would be your scalar, one thing. And second thing, you must know that this energy is basically uh, uh, I mean it is independent of the velocity. So kinetic energy is this thing. What main area we have to discuss here, that is its derivation. What we have to do, we have to derive it. Derivation is something like that, that if a body is, let's say, here, and that body is at rest, its initial speed is 0, and you are applying some force on that body, some force is being applied on that, and that force causes a displacement in that body, and this block is reaching over here, and during this all, its velocity increased to v. Initially its velocity is 0, and its final velocity is v, and in this all game it has traveled through a time t has been passed, right? So I can say that by using the equation of no, sorry, by using the definition of work done is equals to force into displacement, right? And then I told you that if you write this work done as equals to force into displacement is your s, because we have displaced that body by a displacement of s, and now this energy or this work done is stored in the body in the form of kinetic energy, because you are moving this body, but kinetic energy will be applied right at this step, because I'm going to put the displacement from kinetic energy, I mean equations of motion, and those equations of motion are 2as equals v square minus u square, and from here your s is equals to v square divided by 2a. So you are going to put it right here, that is v square divided by 2a. Okay, that is substituted here, and right in this position, if you will say that, okay, according to Newton's third law, F is equals to ma, so you will substitute this value here at,
So what
oh,
happened?
screen is gone.
Yes.
Something bad is happening in my laptop, maybe some virus or is it shared?
And now it's shared.
Okay, yes, so it is shared, but it gone to another position. Yes. So I was saying that actually what happened, that F is equals to MA will be applied here. And when you have applied MA at this position, and V square divided by 2A will be left as it is. then acceleration and acceleration will be gone, and you will get mv square divided by 2, which is basically framed as kinetic energy is 1 by 2 mv square. So you have to keep this point in your mind, that in the derivation of this kinetic energy formula, it is asked to you that which principles are followed. Which principles are followed? First, which principle I followed? I followed the principle of work done is equals to F into S or F into D. Then I use that 2as equals v square minus u square. This is the second equation of motion. And third, I use Newton's second law, that is F is equals to ma. So with the help of these three principles of physics, you reach to this kinetic energy derivation. Is it clear to you?
Yes.
Okay. So after this all, when we used to, or when we reach to the kinetic energy, we have gone through momentum. So I would like to link momentum with kinetic energy right here, because afterwards, maybe I will forget about that. Kinetic energy and momentum, because mostly the questions are asked from this area as well, right? So if I say that kinetic energy is equal to this, relation will be, I mean, this equation will be, will reside till your A levels to, right? mv square, and your momentum is equals to P is equals to m times v. Is it?
Yes.
So if I say that kinetic energy is this one and momentum is m into v, so if I just multiply this equation, like this equation, equation number one, with one more m, right? So it would become m square and v square. But to keep the, equation in its original form, I have to divide it by m as well. So when I am going to divide it by m, I'm using that m in the denominator, and I have used that m in the denominator, in the numerator as well. So this equation becomes, that is 1 by 2m into p square, because m into v is p, so m square v square is basically p square, or you can simply say m into v whole square is equal to p square. So this is that relation which is used to link the kinetic energy and all that stuff. So your kinetic energy is equals to p square divided by 2m. So please keep this concept with you, that if a body has change in kinetic energy, especially in the MCQs question, this concept will help you a lot, right? So kinetic energy is directly proportional to square of momentum. Okay, that is directly proportional to square of momentum. So if body has changing its momentum, then its kinetic energy will be changed. But momentum is affected more. Okay, is it clear to you?
Yes.
Okay. Then after this all, we will reach to the topic of uh, gravitational potential energy. Mechanical is basically, this is the form of mechanical energy. So in gravitational potential energy, the energy possessed by a body due to its height, due to its position from the ground, due to its position from the ground. So if I say that there is a body and that body is changing its position from the height, with respect to the ground, are changing its height, actually changing position with respect to ground mean the body is changing its height. So gp is possessed due to weight and height. So it is basically equals to m G H. It is equals to what? It is equals to mgh. And the main problem with your gravitational potential energy is that when we are talking about gravitational potential energy, it is equals to that formula which is actually linked with mgh. For example, if we are going to lift a body from the surface of the earth, this is a body which is at the surface of the earth, right? And its mass is m, and you are going to lift it at a height h from the surface of the earth. Okay, this is the height h from this point to this point. So that all height is actually, that is the displacement, and that is done against work done, right? Against weight force, that is done against weight force. So you can say that work done is equals to force into displacement, and the force is the weight force. This work is, this w is for work, and this is for the weight. So I'm going to write it directly, and this displacement is f. So write in the form of the setup. If you just go, or if you move on, you can say that weight is basically mg, and that is equal to that. That's it. This is your GPA. Is it clear to you?
Yes.
So I can say that gravitational potential energy is basically that energy which is changed due to potential. I mean, that is changed due to position and weight. The problem is not here. Problem is the interconversion of energy. Interconversion of energy. So when I talk about this topic, that means that energy can be converted from one form to another, right? Energy can be converted from one form to another. So here we follow law of conservation of energy. That law is basically valid in all cases. It is law, na? That's why it is valid. That law states that if a body, yani energy can be transformed from one form to another, but total energy remains unchanged. That is that energy can be transformed from one form to another. One form to other, but total energy remains unchanged. But total energy remains unchanged. Is it clear to you?
Yes.
Or it is conserved? So I can say that energy can be converted from one form to another form without any loss. This is its second perspective, that energy can be converted from one form to another without any loss. Energy can be transferred or converted from one form to another without any loss. Is it clear to you?
Yes.
So, if I say that mechanical energy is interconvertible, that means that mechanical energy has to be converted from one form to another form in two cases. When there is no thermal energy, or when there is no friction, then what will happen? And when there friction, what will happen? So I'm just stating in the absence of friction. In the absence of friction, no energy is lost as thermal energy. No energy is lost as thermal energy. Are you getting this? Getting this point? So I can simply say one more thing, that all of the lost energy, all of the lost energy is equals to all of the gain energy. Okay. So these are actually the major area what you have to discuss, that energy gain is equals to energy lost. Say, is this clear to you? So in
Yes.
this case, I can say that, for example, if a body is moving from height, let's say this body is here, there is a ball, and that ball is dropped from this height. This is its initial velocity. Sorry, its initial velocity is equals to zero, let's say, right? And that ball lost the height, this much height, and at this position, all of its energy, yani total energy, is equals to its gravitational potential energy. But when that ball reaches to this position, at this position, what happens? All of its energy, it has a certain velocity here, definitely. Okay. And all of its energy, total energy, is equals to kinetic energy of that ball here. Is it? Are you agreed with that? So I can say that in this all, loss in GPE equals to gain in KE. Is it clear to you? Yes or not? Yeah, yeah. Do you hear me?
Yes.
So is this setup clear to you? So I can say that GPE is equals to KE. I mean, here you will write delta sign, the delta KE. Right? Loss and gain is something different. We can say change in kinetic is equal to change in potential. So I can say MGH. I can say MGH is equals to what? MGH is equals to KE. That is equal to 1 by 2 mv square. Simply, so your m and m will be gone from here, and you will simply say that to calculate velocity of the object right here, the velocity of the object is equal to 2gh square root. Is it clear to you? The next situation is, if you are going to throw a ball upward, throwing a ball upwards, air resistance negligible, drag, I mean air resistance is drag, up thrust to, so both are negligible or neglected. So in that case, what do you have? you have loss in Ke because the body has some initial kinetic energy that is equals to gain in its GPE. So that gives you same thing 1 by 2 mv square is equals to mgh. So when you cancel out the masses, you get this number that is your height gained by the body is equals to v squared divided by 2g. So this was one of the equation which was used to find the height. Actually, it could be calculated by the same method from the previous equation also. But sometimes I have seen the graphs of height versus speed, that what would be the relation between height and speed, and that is basically drawn in this way. What is your idea that how height and speed would be related with each other? Yes,
So
height
just a
and
minute.
speed. That will be a graph like this. Are you back?
Yes.
Okay. So I can say that here it is velocity, here it is height. So if you have this graph, it would have this type of behavior, right? Is it clear to you? And when height is on the y-axis, v is on the x-axis, then this would be the graph. And in the presence of friction, what will happen? This is the third case. In the presence of friction or opposing resistive force, only friction, right? I'm talking about the friction, right? What will happen? The energy will be lost in the form of heat. Thermal energy, you can say. For example, when you are going to apply the brakes, what will happen? You will waste the energy in the form of heat or in the form of thermal energy. So energy is lost in the form of thermal energy, and that means that loss in energy will not be equal to loss in energy will not be equal to gain in energy. Okay, is it clear? So,
Yes.
for example, I can say that loss in energy will be greater than loss in energy will be greater than gain. Gain will be less, definitely. Gain in energy. Okay, yeah, yeah.
Yes.
And that means that some of the energy will appear in the form of heat. So I can say that loss minus gain is equal to thermal energy. That is why I told you that in the previous case, loss was equal to gain. I mean to say, if I go back, I can say that infinix. In this case, loss and gain was equal. So if you subtract them both, you get zero answer. Yani loss minus gain when they were equal, answer was zero. But in the case of thermal energy or in the case of friction, it is not like that. What will happen then? Loss and gain is not equal to zero. It is equal to thermal energy, or you can say that work done against friction, right? Or work done against friction. Is it clear to you? So if I say that loss in kinetic or loss in potential, sorry, because when I told you in the first case it was loss in potential, that loss in potential energy minus gain in kinetic energy, that will be equals to work done against friction. Work done against friction. Okay, is it clear to you? Yes. So this is basically that formula which I usually use. So for example, if I say mgh, and change in mgh will be used here, minus change in 1 by 2 mv square, or change in kinetic energy. Sorry, just leave that change here. Just put the values. When you will subtract these two numbers, you will get work done against friction. So it will be F into D. And if I want to find the frictional force, in this case, that frictional force is basically equal to what? That is equals to F, yani difference of energies divided by displacement. So frictional force is equals to what? Difference of energies. Okay, difference of energies divided by distance traveled, or you can say displacement. Is it clear to you?
Yes.
Okay. So this was basically the first area. I mean, almost we are done with this. Um I will discuss in the next class with some of the examples with you, and inshallah that lecture will be done. That topic will be done by the next lecture. Okay. Okay. Yeah. Yeah.
Yes.